I'm going to briefly describe like what Next-Gen Kaldi is and who the team is and what we're working on. I'm going to give you a brief summary of some of our recent like technical work and recent papers we're publishing about accelerating RNNT. But then most of this talk, I want to describe something else that we haven't yet published, although I guess this technically is a kind of publication. It's about a reworking of the conformer encoder, which is, conformer is just a modified transformer. This is a lot more technical than the other talks. I'm just trying to find something that I think is going to be interesting to most of the participants in this conference. So you'll when I get to that part, you'll see what it's all about. But so let me start with the Next-Gen Kaldi intro. So the Next-Gen Kaldi actually describes this cluster of three different open source projects. Actually, these are just the main ones. We have a bunch of smaller ones that kind of implement extra features for them. But so LOTC is all about data preparation for speech recognition. It's like, so in speech recognition, the data preparation is much more complicated than, let's say, computer vision and things like that, because the utterances are all different lengths. There's all kinds of issues about how to put them in batches and things like that. Like, we've made a whole repository about that to keep it separate from everything else. Then K2 is a bunch of core algorithms in C++, things like lattices and finite state transducers. And then Icefall is the recipes. And right now, most of our effort is going into Icefall. And Icefall is developing very rapidly. It's not super stable. You know, we change the recipes every week or two, but we've structured it in such a way that we can make rapid progress. Later on, we'll clean it up a little bit. Now, right now in the recipes in Icefall, we're mostly working with RNNT. And technically, it's not an RNN. It's not, because we don't really use LSTMs right now. We're mostly using transformers. So technically it's a transducer, but we use the word RNNT because that's what it's called. So Icefall doesn't have any Kaldi dependency. It just depends on PyTorch, although it does depend on these other repositories, K2 and LOTC. Right now, we put a lot of effort into fast RNNT training. We're focused on things that can be practical to build real speech recognition systems. And we're also working on another project called Sherpa that has the runtime, like so that you can build a server that does real-time recognition, things like that. But this is in a very early stage. So to compare Next-Gen Kaldi with other popular toolkits, probably the most popular kind of PyTorch-based toolkits, or most popular Python-based toolkits for speech recognition right now are SpeechBrain, ESPNet, and WeNet, although there are others. Compared to SpeechBrain and ESPNet, we're much more focused on just speech recognition. Those projects have quite a wide range of interests, including TTS and speech separation. Right now, we're just focusing on ASR, and our main focus is to be something practical that companies can use to build real speech recognition systems. And I don't want to say that this is ready. This is not 100% ready yet, because we have not finished all the issues about real-time recognition, but we're working very hard on it right now. We're different from WeNet because we don't have any Kaldi dependency. We're trying to build everything kind of from scratch, although it's based on PyTorch, so it's not totally from scratch. But you know, we're taking inspiration from these other projects too. We've used code from ESP.NET, from WeNet. Okay. So the basic vision of Next-Gen Kaldi is to have low latency speech recognition that's accurate, that has high throughput, so you can do the server inference very efficiently. This is something that the other big toolkits, SpeechBrain and ESP.NET, are not focused on at all, as far as I can tell. Another thing we need, so we want to be able to use this in all of Xiaomi's products, as well as being open source, right? So there's certain requirements. Apart from the high throughput and low latency, we also need to support contextualization. For example, if you have names of contacts or you have a database of music song titles, you need to be able to somehow put that into the system. And also to specialize it to particular products, like suppose you have an air conditioner or something that has certain commands. This is something that so-called end-to-end speech recognition is not very good at. Like, people can get super impressive numbers on LibreSpeech with RNNT or with transformer transducers, but when you try to actually build a product with these things, you realize that there's actually a lot of problems with it. So anyway, I'm very committed to getting something working. This has taken a lot longer than expected, but at some point, you know, we're really going to have something working, and I hope that's going to be by the end of the year. So, like I said, we were hoping that we would have already released something like a year ago, and I've never been very good at estimating timelines. And I guess I didn't take into account how long it would take to build up a team and to learn the things needed, because I was always coding in C++ and CUDA. I was never a very big Python programmer, so I had to learn a lot of things. And also, we've changed direction quite a lot, because originally the plan was to keep most of the Kaldi code, but use PyTorch for the neural net stuff. But in the end, I decided that it was just going to be too much code. It was going to be too much legacy. And I decided it was not a good plan. And the next plan was, we built K2 with the intention of focusing mostly on finite state automata, things like lattice-free MMI, CTC. But we couldn't quite get the word error rate results that we were hoping for from that. Now, K2 is still very useful, because for a start, you can use finite state automata for a lot of things, like lattices are a data structure that you're going to need for any serious speech recognition system. And secondly, the way we built K2, it's based on these primitives called the ragged tensors, which is a very useful data structure for implementing algorithms on GPU that have irregular structure. So let's say fast RNNT, we used some utilities from K2 to build that. And RNNT decoding, we also used K2. It's some very useful primitives there. So even though we switched focus a little bit from lattice-free MMI to RNNT, it's still very useful.